how's it going? This is Mike coming back at you with another video on discrete mathematics. In the previous video, we looked at quantified statements, and we talked about what do the negations of these things look like. How do you take the negative of a quantified statement? And we said that there's two components to every quantified statement. There's the quantifier, and then there's the statement form that follows it. So when you take the negative of a quantified statement, you negate the quantifier, and when you take the negative of a quantifier, you switch it to its opposite. So for all becomes there is, and vice versa. And then you take the negative of the statement form that follows it. So in this video, we're just going to do a few more samples here. We'll take the negative of the given quantified statement. Some of these we'll see written as an English statement or sentence, and we'll write the final answer in that form. So first one up, I'm going to take the negative of for all x in D, not p of x and q of x. So for this guy, this is the quantifier, and then that is the statement form. So when we take the negative of a quantified statement, as I just said, we take the negative of the quantifier. So this for all is going to become there is. There we go. There is x in D, and then we take the negative of the statement form here. So not of not p of x, just going to be p of x. And when we take the negative of a conjunction, it switches to a disjunction, and then not q of x. So this is exactly what we get in our next slide. There exists x in D such that p of x or not q of x. You'll see me write the s period t period. That's just short for such that. Next up, there exists x in D such that q of x implies not p of x. Try to figure this one out on your own. So pause this video here, take the minute or two, see if you can figure out what the negative of this is going to be. And once you think you have it, press play, and we'll see if you were right. All right, so let's see if you came up with the correct answer. The negative of this quantified statement, you have an existential quantifier. The negative will contain a universal quantifier. So there will be a for all there. And then you have this conditional statement here. Q of x implies not p of x. We talked about the logical equivalence of a conditional statement. So we're going to use that logical equivalence to then be able to more easily take the negative of what we have. The logical equivalent of Q implies not P would be not Q or not P. So when we take the negative of that, we get Q of x and P of x. So the entire negative of the given statement is for all x in D, Q of x and P of x. Here's an example of a sentence. All Buffalo State students wear orange and drive a car. So now we have to take this English statement, this English sentence, translate it into a quantified statement, perform the operation of taking the negative of that quantified statement and then changing it back into a sentence. So take some time, try to think about how we can just take this sentence and turn it into something with these quantifiers. If you think all Buffalo State students wear orange and drive a car, it is a little bit odd and a little bit challenging to try to think of it, but it's not too bad. Once you think you have this sentence as a quantified statement, take the negative of it and then sort of translate back into English what you think that's really saying. So pause the video here, think about it. Once you think you have it, press play and we'll see if you were right. All right, so let's see if you were correct. How can we take the sentence and think of it as a quantified statement? Well, there's the all Buffalo State students there. So I can think of that in the world of logic and quantified statements as saying for all Buff State students X, then we have, so all Buffalo State students wear orange and drive a car. That's like saying X wears orange and X drives a car. So for all Buffalo State students X, X wears orange and X drives a car. So we see that we have a universally quantified statement here, and our statement form contains a conjunction. X wears orange and X drives a car. So let's take the negative of that. The universal quantifier is going to become a conditional quantifier. So the negative, all right, NEG for short. We can say there is a Buff State, BS for short, students X, such that, so that is the negation of our quantifier. Now we take the negative of that statement form. So we're given a conjunction. Now we're going to end up with a disjunction when we take the negative of it. So the negative of X wears orange and X drives a car is X does not wear orange and X does not drive a car, such that X doesn't wear, so that X does not wear orange, or X doesn't drive a car. So this is the semi-mathematical logic way of saying it. This is the semi-English way, kind of. But let's take, there is a Buffalo State student X, such that X doesn't wear orange or X doesn't drive a car. And let's put that into a more common way that we would say this in just an everyday conversation. The way we would say that is some Buffalo State students don't wear orange or don't drive a car. Yes, it does sound like in this sentence that we are implying that it's always more than one. while technically it could only be just one student, but technically it is possible that there is only one Buffalo State student that doesn't wear orange or doesn't drive a car. And this is just a matter of semantics and just how we would say things in our everyday conversation. Last thing I want to talk about and go over in this video is writing the inverse, converse, and contrapositive of a given quantified statement. So suppose you have this statement right here. For all x in R, that's the set of all real numbers. If 5x is less than 245, then x is less than 49. So we're going to write the inverse, the converse, and the contrapositive of this given quantified statement. Now think back to the previous video when we said that writing the inverse, converse, and contrapositive does not change the quantifier that we use. So our given quantifier was a for all, so that means every one of these three answers that we're looking for is going to contain the for all x in R piece. What's going to change is the statement form. So the inverse, as we said, going back to the previous chapter, inverse is when you take P and Q and you take the negative of each and you do not P implies not Q. So the inverse will be for all x in R. 5x is not less than 245, which is the same as saying 5x is greater than or equal to 245, implies x is not less than 49, or x is greater than or equal to 49. The converse of P implies Q, you take P and Q and you switch their places. You now have Q implies P. So the converse would read for all x in R, x is less than 49, implies 5x is less than 245. And then contrapositive, you're given P implies Q. You switch the places of the two to give you Q implies P, and then you take the negative of each of those two things, giving you not Q implies not P. And what you get with that for this given statement is for all x in R, x is greater than or equal to 49, implies 5x is greater than or equal to 245. And just as a final note, if you think about these three statements here, the inverse, the converse, and the contrapositive, and you think about them, those are all necessarily true. Those are all saying the same thing. Now, why is that the case when we're talking about a conditional, or it's presented as a conditional, when we know that a given conditional and its contrapositive are logically equivalent, and the inverse and the converse are logically equivalent, but between those, they're not necessarily. Well, that's because although this right here was presented as a conditional, in reality, this is actually a biconditional. The 5x is less than 245 is true if and only if x is less than 49. So this is something that you may encounter later on in this course, or in higher mathematics courses if you go on to take them. You may encounter cases where you write the contrapositive, the inverse, and the converse, and they all make sense. They all seem to be saying the same kind of thing. And if that's the case, then what you have is actually a biconditional statement, although it's presented just as a conditional. So these were just a few more sample problems just to help us get used to writing the negative of a quantified statement. seeing again how you take sentences that we use in everyday conversation and seeing what those guys can turn into, and then just a quick sample problem about the inverse, the converse, and the contrapositive. Nothing changes with those. It's only, or we're just adding in the context of quantifiers and the inverse, converse, and contrapositive. As we just said, nothing changes. If you have any questions or comments, please be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.